Question 4 is about extracting aluminium from aluminium oxide using the process of electrolysis. You're asked to comment on whether these statements are true or false. The first statement says melting pure aluminium oxide uses more energy than melting a mixture of aluminium oxide and cryolite. If we look at the information given above the diagram, it tells you that the melting point of pure aluminium oxide is around 2000 degrees Celsius, whereas melting the mixture is 900 degrees Celsius. Therefore, melting the pure aluminium oxide would take more energy, so this statement is true. After the mixture melts, it contains ions arranged in a regular lattice. You have to look closely at this statement. It says a regular lattice. Well, once the ions have melted, then the arrangement will not be a regular arrangement. They will be disordered. So this statement is false. The melting point of aluminium is above 1000 degrees Celsius. Well, this is also false because it says that there is molten aluminium at the bottom of the tank, but the process occurs at 1000 degrees Celsius. So around 1000 degrees Celsius, the aluminium must be a liquid, and therefore the melting point must be lower than 1000 degrees Celsius. A gas is made at the positive electrode. If we look here, these are the positive electrodes, and it's true that a gas is made there. The gas that's made there is oxygen. And then below 900 degrees Celsius, the mixture does not conduct electricity. This is also true, since below 900 degrees Celsius, the mixture will be a solid, and solid compounds do not conduct electricity. For part 2, you are asked what happens to aluminium ions at the negative electrode. Okay, so at the negative electrode, aluminium is made, so we have to get rid of the 3+ charge that's here. We do that by gaining electrons. Remember, electrons are negatively charged, so if the aluminium 3+ gains 3 negative charges, it becomes a neutral atom. So the way in which it can do that is by gaining 3 electrons. So to get 2 marks, you need to state that the aluminium ions will gain electrons, they will gain 3 electrons, and you could also put that they form aluminium atoms. You need to use the word atoms to get the mark if you're going to go for that one. So you only need any 2 of these 3 points to get the 2 marks. Part B tells you that copper can be extracted by heating copper oxide with carbon. It tells you that the products are carbon dioxide and copper. It asks you to write a balanced symbol equation. So you start with the copper oxide and you react it with carbon. You make carbon dioxide and copper. You should then notice that you need 2 oxygens to make the carbon dioxide. So because of that, you have to put a 2 in front of the copper oxide. And then you've got now 2 coppers at this side, so you're going to have to balance that up on the right hand side and make 2 coppers here. So you get 1 mark for getting all of the correct formula. CuO plus C makes CO2 plus Cu, and then 1 for balancing, so for having a 2 before the copper oxide and a 2 before the copper. Part 2 asks what reduction means. So reduction is the removal of oxygen, or can be defined as the gaining of electrons. Remember, oxidation is loss of electrons, reduction is gain of electrons, oil rig. It's not possible to extract aluminium from aluminium oxide by heating with carbon, and that's because carbon is less reactive than the aluminium, so it won't pinch the oxygen away from it, or aluminium is more reactive than the carbon.